Welcome and hello. This is a video exercise in the FHWA hydraulic toolbox, and I've titled this exercise Rolled Erosion Control Products and Stable Slopes. So what we're going to be doing is going up to the calculators menu and adding a new channel lining design analysis. And then for the lining type, this top drop down, we're going to be dealing with rolled erosion controlled products. All right, as a way of introduction, I've got a slide that outlines where we're going. What we want to do in this exercise is find the channel slope that maintains stability for rolled erosion control products, RECP, types 1B, 1C, and 1D. So we want to identify the range of slopes for each of these erosion control products. So for instance, we have three different options. We have 1B, 1C, and 1D. 1B is the lightest, weakest, probably the least expensive. 1C and then 1D, I assume, is the strongest, heaviest, and most expensive. So the idea here is if you have a channel that has different slopes, you probably don't want to be using the most expensive erosion control on the slope that only needs the least expensive erosion control type. So some of the product specifications for these different rolled erosion control products, as well as the calculator and our given trapezoidal channel, which we see the specs for right down here, will give us an idea of which different rolled erosion control products to be using for the different slopes along the channel. All right, so let's go ahead and get started. Again, we have the given trapezoidal channel dimensions right here. We're going to be using this for our data input, and then we have some of the soil material as well. All right, so if you wanted to just try this on your own, go ahead and take a screenshot or remember these numbers. Otherwise, I'm going to go ahead and just knock out this exercise on my own. As far as the slopes go, I'm going to be reporting to a precision to the nearest 2 decimal places of a percentage. So for instance, 0.45% would be in a decimal form 0.0045, or if the slope is 1.35%, that would be 0.0135 in decimal form. I should also probably mention that I'm going to be referencing this FP14 document, specifically table 713-3. I'll leave a link in the description of this video where you can download it, but it's called Standard Specification for Construction of Roads and Bridges on Federal Highway Projects, FP14. And for this particular version, it is page 694, where I'm finding this table 713-3. We'll return to this table a little bit later in the exercise. All right, so we are back in the calculator. This is the channel lining design analysis. I don't have a separate channel calculation or channel analysis developed. What I'm going to do this time is just create that channel data right here within the channel lining design calculator. So I'll click on Create New and then click on Channel Calculator. All right, so I'm going to put in some of the data that I had listed on that problem statement. So the type is going to be trapezoidal. Side slope is 4:1 on both sides. The channel width is going to be 3 meters. So if you don't already have the metric unit set, click OK. And then, I guess you have to click OK here. Go back to units, switch to SI units or metric. There's also a drop down for that. Okay, back to my channel lining design analysis. By the way, it's already created a separate channel analysis that's being used by the channel lining design. So basically the same thing. If you do it separately externally, or you create that channel details within your channel lining calculator. Okay, back to our channel calculator. Trapezoidal 4:1, channel width is 3 meters. That's the base width of the trapezoidal shaped channel. Next is the longitudinal slope. Now this is the parameter that we're going to be changing. So I'm going to just, I don't know, arbitrarily type in 1% for now, but we're going to return to this a little later. Manning's roughness, that was given as 0.035, typical for soil. And then the flow rate is going to be 1 cubic meter per second. So go ahead and click Calculate, and then click OK. Again, that slope of 1%, something we're going to change a little bit later, but let's carry on with our input. Further down, we have the input parameters that's specific to the channel lining design calculations. The first thing we need to input here is the shear stress on the RECP product. So let's go ahead and revisit that PDF file, table 713-3, temporary rolled erosion control products. Across the top, we have the different types. There's 1A, 1B, 1C, 1D, and then it goes 2A, 2B, and so on. We're interested in 1B, 1C, and 1D. And then down below in each of the rows, there are some product characteristics, such as the typical functioning longevity, minimum tensile strength, and so on. What I've noticed is that if it starts with a 1, it's typically a 3-month longevity. If it starts with a 2, it's 12-month longevity. If it starts with a 3, it's 24-month longevity. And then if the letter is A, then you're looking at a minimum shear stress of about 0.25 pounds per square foot, 0.25 pounds per square foot, and 0.25 pounds per square foot. If you're looking at a B, that's associated with 0.5 pounds force per square foot. And then C and D have their own minimum shear stress as well. And then for metric units, it also shows the number of pascals. So since we're using metric, we're going to be using pascals. So let's go ahead and investigate from the cheapest or the least amount of erosion control up to the most. So we're going to start with 1B and then 1C and then 1D. What we care about here is that minimum shear stress of 24 pascals, 72, and 84. Okay, so since we're starting with 1B, this 24 Pascal value or 24 Newton per meter squared, that's the value that we want to input right here for the shear stress. So we'll type in 24. All right, so the next field down is the input Manning's value as user supplied or manufacturer supplied data. I'm just going to use user supplied. So we've already added that in our channel data. And then the RECP type, this is another thing we need to set as erosion control blankets. So back to that PDF file, 1B, 1C, and 1D have definitions. Well, all the types have definitions a page or two up. So 1B is erosion control blanket, 1C erosion control blanket, and 1D erosion control blanket. So we could just set that one time as erosion control blanket right here, and we're done. All right, the specific weight of water, that's good. That's fresh water. And then some of the soil properties we were also given. This is actually a cohesive soil. It's a sandy clay, yes, SC. So that's already selected, SC. The plasticity index is given as 8. The void ratio is given as 0.5. And then if we scroll down here, we have a safety factor of 1.1. Okay, so we'll tab off and then scroll down. We're going to say 0 circular radius. So effectively, we're analyzing a straight channel, no curvature. But we do have a message that tells us that based on this particular channel and flow rate and erosion control product, that the channel bottom is not stable and the channel is not stable. So what we need to do is change the slope to something less than our original guess of 1% to the point where this channel bottom does become stable for the first erosion control product, which is 1B. All right, so what I'm going to do is scroll up, go to Channel Calculator, change the longitudinal slope to 0.001, so that's 0.1%, calculate, click OK, and then scroll down. Since we have green text here, it says the channel bottom is stable, the channel is stable. All right, so I'm just going to continue that process to figure out what is the maximum slope at this particular rolled erosion control product. How about 0.005? So that's 0.5%. I'll click on Calculate, OK, scroll down. The channel bottom is not stable. We're just going to keep repeating this process. So we need to choose a smaller slope. How about 0.003? Calculate, OK. Still not good. So it's actually less than 0.003. Back up to click on Channel Calculator, 0.002. I'm just splitting the difference right now. Calculate, OK. Scroll down, and we're good. So that the maximum slope is between 0.2% and 0.3%. This is again at our 1 CMS flow rate. So all of the input parameters are affecting these calculations. How about 0.0025? Click Calculate and OK. That's good. That's good. So 0.0028, calculate. Okay. That's not good. So it's either going to be 0.25, 0.26, or 0.27 as the maximum. We already know it's 0.25 passes. So let's try 0.27. Calculate. Okay. And that's not good. So it's either 0.26 or 0.25. 0.25 already passed. 0.26 is also good. Okay, so 0.0026, that's 0.26% is the maximum slope that this erosion control product 1B can withstand based on our flow rate and our channel geometry as well as the soil properties. Okay, so next up is going to be 1C. So if we increase the minimum shear stress from 24 up to 72 pascals, basically tripling that stress, we're definitely going to be able to withstand the current slope. In fact, let's go ahead and change it to 0.0027. I'll tab off, calculate, okay. And then, of course, that failed. So we're going to increase that shear stress from 24 newtons per meter squared up to 72 newtons per meter squared. Newtons per meter squared is the same thing as pascals, that PA that we saw in the table right here. PA is the same thing as newtons per meter squared. Okay, so with 3 times the amount of shear stress, of course, it passes. Let's repeat that process by increasing the slope until we have a slope that doesn't pass. So just using a round number here, I'll say 1%. A flow rate still 1 CMS. Calculate. Okay. Scroll down. Okay. So this can withstand more than 1%. Let's check out how about 1.5%. Calculate. Okay. Scroll down. No good. All right. So it's between 1 and 1.5%. 0.012. Tab off. Calculate. Okay. Scroll down. 1.2% passes. So I'm just going to split the difference here. About 1.35%. Okay. Scroll down. Doesn't pass. Okay. 0.0. How about 128? Calculate. Okay. Doesn't pass. So between 1.2 and 1.28, let's test out 1.24 and scroll down. Not good. So how about 1.22 as the slope on a percentage? Calculate, scroll down. No. So it's either going to be 1.2 or 1.21. 1.21. Let's check that. And that is good. So 1.21 is the maximum percent slope that can withstand the 1 CMS for our rolled erosion controlled product type 1C. That's 72 pascals. So what I want to do is keep track of some of these numbers, which I've already been doing. I need a 0.0121 is the maximum slope for 1C. So for 1B, there really is no minimum slope, but I'm just going to put 1, 2, 2 now, because if the slope was less than 0.0122, I would use rolled erosion controlled product type 1C. And if it was less than 0.27%, I would downgrade to 1B. Let's go ahead and find the maximum slope associated with this last type 1D. Okay, so we identified 84 pascals is that minimum shear stress. Let's go back and change that now to 84. And then let's increase the slope. So how about, let's go with 1.5%, tab off, calculate. Okay, scroll down. Interesting. So 1.5% is too high of a slope. Let's go back to the channel calculator. How about 1.4%? Calculate. Okay, scroll down. Okay, so it's between 1.4% and 1.5%. Okay, off camera, I went ahead and did the calculations. It's 1.49%. So 0.0149. If I click on calculate and click OK for the 84 newtons per meter squared shear stress, that passes. But as you saw, 1.5% or 0.015 fails. So let's finish up that table. I'm going to go with 0.0149. All right, well, this is it. This is our final results where we identified the minimum and maximum slopes that should be used for the different RECP, rolled erosion controlled products for this particular channel geometry and flow rate and soil materials. So if your channel slope is exactly 1%, that's within this range. You're going to want to use 1C. If it's less than 0.2%, use 1B. And if it's between 1.22% and 1.49%, 1D is the rolled erosion control product to use.